on this particular unit, we can do that. Which one's it for? Channel 1 or channel 2?
It's going up.
Yeah.
3991, 2.
Hey man, can you pull the transformers out?
Wow. Yeah.
No, because that's asking for a whole other set of issues if it's not designed that way.
Yeah.
So.
Yeah, now it's going down. 74. There. They're plug and play. And this is the second. You can call me out if that's not true when the videos are out. Stay safe. All right, Joe is working on the API.
Yeah, we are.
All right.
So first things first, we have it plugged in. We have our controls at flat. We don't have it in bypass. And looking at with our audio precision machine, we can look at all kinds of cool things.
Awesome.
Starting off with, here's our tone generator, which are generating a sine wave, which we typically will use for testing gear. We're generating a +4 dBu signal, which is standard line level. So we can see that we got a 1K frequency coming out and coming back in. We can see the level returning, which is about less than a tenth of a dB, or about a tenth of a dB between channels, which is really good. We can look at noise ratios, and we can look at noise levels. So channel 2 is slightly less noisier than channel 1.
Let me see close up here.
Yeah.
All right.
And you can see her harmonic distortion content and so forth. So starting off, you'll notice channel 1 is about 3 dB noisier than channel 2.
Yeah, it's that hum that we talked about and we were trying to fix.
Yeah, and you'll notice that you got slightly more noise in channel 1 than channel 2.
Okay.
So starting off, let's run a frequency sweep. Go back to that. And we'll run a sweep across the entire unit. See how flat it is. So that's pretty good. There's your less than a tenth of a dB.
Oh wow, that's pretty impressive.
So I mean that's really good right there.
Yeah.
You can see some slight differences in the very high frequencies, but that's well above like 30K.
Okay.
If I were to do something like this, for example, pick a midband, do that. That. So you can start seeing where we're graphing the EQ out. That's the midband at around 3K.
Okay.
On both channels. And then I could do the opposite. You should see in the middle. And get it to where it looks like this, like you see in most of the manuals.
Yeah.
Yeah. That's a nice spell. That's nice and wide.
For those who are not familiar, the API has a proportional Q.
Correct.
So the more you boost and the
more narrow it gets. Absolutely. If I wanted to, well no, that's at ×1. So we're gonna pull the lid off. Oh, sorry. Lid on. So, is there any particular reason why you're running different op amps?
They were changed by the original owner because they were the original API blew up. Can we try to swap them really quick and see if the...
Yeah, we can definitely swap them. Yeah. They're interchangeable. The APIs are on sockets, as is the others. I'm assuming those are Scott Liebers.
Yeah.
Hey, all right. Scott does really good work, so I can't knock his stuff. But yeah, we can definitely do that. There's other things we can look at as well. So for starters, you have your nice transformer over here. Depending on how the transformer is orientated, it could sometimes increase or decrease EMI interference. So a lot of times what some people will tell you to do is slightly rotate the transformer a little bit.
Yeah.
See if the noise increases or decreases.
Yeah.
Ideally, you're canceling out the wavelength when you do that. So that's always a possibility. But let's start off by swapping op amps around, because we can.
Awesome.
We got two 2520s per channel.
I sold all my API gear before because they kept blowing up.
Right.
Until I changed.
I can tell you why the APIs tend to blow up.
Tell me.
Yeah. They're epoxied, and they're epoxied for a good reason.
Yeah.
Theft prevention.
Oh, really?
Yeah, they don't, like most people, if you do something really good, like they've done over the years, everybody tries to copy it.
Yep.
That's why Howard Dumble would epoxy his amps and so forth.
Same for the distressor.
Mm-hmm.
They sand, all the components inside.
Yeah. Publison used to do that too. And they would sand off all the numbers on their chips, and then they would just put a dot of paint in a color. And unless you were an authorized Publison repair person, you never had the color decoder.
The color code.
So I knew a few guys who were authorized, and they had the little color charts, and it would tell you what chip was what, and so forth. So so they epoxy them for theft prevent.
Awesome. I didn't know
Protection
that.
of their intellectual property. They'll tell you things like it's for thermal dissipation and so forth.
Yeah.
But you're actually better off leaving them open, like what Scott Liebers does.
Yeah.
So, fast forward to the internet and everybody having schematics, and someone in the working world put out a schematic of the 2520 op amp. According to API insiders, it's incorrect, but it's the one that everybody started to make API copies from.
Right.
So, I can't confirm its validity. I can just tell you that someone said it was a 2520 op amp, and it had all the discrete components in it, and it was close enough that people started making them.
Yeah.
So, in protecting their intellectual property, being epoxied, it's great. However, under thermal conditions, the boards flex, like every other circuit board, and eventually they will fail because as they flex and unflex, you're pulling on components that are glued in place. So...
yeah, of course. They lose electricity, and then at some point...
so they do cause things to break that way. But here we are. We've swapped op amps from channel to channel.
Okay.
Starting off, we have the 2520s now in what's this channel and the Scott Liebers in that channel. And we'll see if that does anything. I don't think it will, but you never know.
Yeah.
So going back to looking at our wonderful main outs, we still have our 3 dB noise floor difference. Oh, and that's why we have our level difference, because we have our EQs in. So now we should see close to +4. On our monitors for our inputs. Yeah.
It's 3.982 and 4.00.
Yeah, so you're about matched in channels. Yeah. Some manufacturers allow you to adjust channel gain separate from what the EQ and the boost and cut are doing. So for example, here's our flathead. On this particular unit, we can do that. So, if it were me and I was working on it, which one's it for? Channel 1 or Channel 2?
Channel 2 is 4, and Channel 1 is 3.982.
3.9.
It's going up.
Yeah.
3991, 2. I think you can leave it there.
Yeah.
It's like 009, 003.
But there you go. So, like, for example, there's an overall gain structure for the op amps.
Yeah.
That you can adjust separate from adjusting the EQ. So we've done that to match the channels even more. Most companies will do that. Some companies will have actual trim pots on each individual gain pot.
Yeah.
Like what we did at Avalon to get the maximum amount of matching between channels and so forth. And
I remember even the 2500, I had a trim for matching, and then a billion little screws inside.
Oh, yeah, of course.
For the VCA, for every kind of stage.
Oh, yeah, absolutely. So looking overall at the unit, here we have our power supply design.
Yeah.
You can see that they put LEDs on the inside.
Yeah.
Which indicate that your power rails are working, which is +16 and -16. And apparently there's a +24 as well, which I'm not quite sure what the +24 is for, but it's there. My guess would be to run the LEDs.
Okay.
And to run all the LEDs.
On the front. Yeah.
So yeah, now that we have that done, let's move on to our transformer and see what happens when we rotate it. Watch the smoke come out. No, that's that's not going to happen. So we do have play in our transformer bit, and you'll notice where the noise should probably change just a little bit.
Okay, so you're just twisting that.
It may get better, it may get worse. We don't know.
I don't remember how it was before. Now we got 73 on channel 1 and 77 on channel 2.
Yeah, so it got worse.
Yeah.
So,
Yeah, now it's going down. 74. Now it's back to 73. 73.7. 74. Yeah, there.
Okay. That might be as good as it gets.
Yeah.
You know, normally when you do power supply designs, most people, especially in the olden days when they would do gear, is the transformer would be in its own separate compartment. If you look at things like an Avalon 737 or other manufacturers, and this isn't anything on API, this is just what we used to do.
Yeah.
The power supply would either be in a separate box altogether, connecting to the unit, or in the unit.
You mean external?
External.
Yeah.
And if you can't do external, then you try and isolate it either by having a separate part of the chassis, blocking it off with shielding and so forth. So that's, a lot of people do it this way.
Mm-hmm.
It works. But if you're noticing like noise issues, there's ways to combat it, and that's usually the easiest way. So like, for example, if you look at an Avalon 737, the power supply is a chassis inside the chassis.
Mm-hmm. Makes sense.
So it's a box within a box within a box.
Right.
What we noticed, and especially what I noticed in my time there, is how much a layout can affect things. In particular, the 2000 series, for example, that they found out a long time ago that the power transformer is best suited to live in its own separate box as far as noise.
Right.
So they have noise floors of over negative 91 dBu in rack gear, running high voltage and so forth. And they do that because they can have the transformer external. There's a mastering engineer who wanted me to do this with all his gear. Hey man, can you pull the transformers out?
Wow.
And have them in their own little boxes?
Yeah.
And I'm like, no.
Yeah.
No, because that's asking for a whole other set of issues if it's not designed that way.
Yeah.
Mainly running live AC voltage at long lengths, you know, across your floors.
That was the thing that I was going to ask you, because I saw someone doing this with this unit.
Yeah.
Just put in the a couple of cables, just plug in 2 holes in the back of the unit, which I would not ever do that. Because, well, first of all, let's say this. Mm-hmm. This is a unit that has been around forever and is like in half a mastering studio, so has nothing wrong with the unit. I just was curious because I know you, because we are friends. I had the chance to bring it and have you take a look at it.
You could definitely do that. I don't know how better or worse it would make it, because I've never seen it measured that way.
Yeah.
But it is possible to pull the transformer out and have the transformer in its own box. But then you start looking at what you're doing with that, and unless you design it that way, you have a long length of AC wire running across this way and then running back that way into the unit.
Yeah.
It comes from your AC plug, past the power switch, into the transformer, and then out of the transformer into the rest of the power supply. You know, I know guys who have talked about doing that and tell you how great it is, and other people are like,
Yeah.
You know, so, like, for example, with the Avalon stuff, and I like to reference them a lot because I spent so much time with them. They're all good friends of mine.
Yeah, of course.
And for the fact that ultimately I think they design gear correctly.
Yeah.
When you have negative 91 plus dBu noise floors.
It's pretty goddamn
and,
good.
you know, you're in 0.001% harmonic distortion.
Yeah.
At nominal operating levels. You're in the right way of doing things from a design point of view.
No doubt.
You know, so like, for example, their 2000 series, which has the external transformers, it's the shortest path possible. You have the power plug on the actual box. Coming out of the box is your 4-pin right into your unit. So it's not the long path that you would want here, or that you would get here by doing that. I can't think it would get better or worse, but I can tell you rotating the power transformer,
it does change, yeah.
Change things a bit,
yeah.
Because you're starting to cancel the EMI wavelengths out of it.
Some people were saying like, oh, it depends what unit you have on top or next. I put this one on my side rack and there's nothing above it.
Yeah.
And there's only one compressor in there. And even when it's turned off, it has the same noise, so nothing changes. So
well,
it's just...
There's a couple schools of thought on that. First off being, you want to separate rack gear because of thermal dissipation.
Of course.
But ultimately, at the end of the day, if it's designed right, which this is designed pretty well.
Yeah.
You know, the layout's really nice. You know, when it comes to stuff like this, because all the boxes are shielded, in a perfect world, they shouldn't have any issues whatsoever. Can't say that doesn't always happen. With most companies, they spend a lot of time on the test bench before they actually release a product, which is why it takes as long as it does when you have to design from the ground up to do things. You know, not every company does that. Especially nowadays, it's so much easier to copy what everybody else has done.
Yeah.
You know, and we can make an API just like you can. And then you start going, well, it's not an API. And it doesn't sound as good, and it doesn't do this, it doesn't do that. I've known the guys from API for a long time, and they're really good friends of mine.
Yeah, they're good people.
So I can't say nothing bad about their stuff.
Oh, absolutely.
Mainly because they don't make anything that's bad.
No, they really don't.
They, especially when they got resurrected by Paul Wolf, they started doing things where it's just like, holy shit. The 2500 in particular, that compressor, unfucking believable.
I've had it for like 10 years, and it's amazing.
And we don't have one yet, but it's coming. Looking at the 2520, for example, they've gone through design revisions on that over the years, based on part availability and so forth. That's why you get some API aficionados who are like, you have to have the Huntington ones, or you have to have the ones made, you know, here or whatever.
Yeah.
I've had some people tell me that even the latest API ones sound different because they're using surface mount components and they're not using the standard full through hole components. I don't know if that's true. For me, if it works and it sounds good to you, I'm happy and we're done. I don't debate this op amp versus that op amp because I'm approaching things differently.
Yeah.
I just want it to run and sound good to whoever's using it.
Yeah.
So to say, would there be much of a difference between the Scott Liebers versus the APIs? Probably not, because they're pretty much similar designed. I think you'd find more of a difference if you stuck in a Melcore 1731,
right,
or a Jensen 990, or which is now made by John Hardy, you know, or even a 918 versus like, oh, I swapped the 2520 for another 2520.
Yeah, exactly.
You know, so
we close this up for now.
Yeah,
you say?
I think so.
And yeah. That was pretty interesting to see. Better than before. All right. Thank you so much.
Oh, no worries.
Joe. And I'll see you later. Surprise live stream here on Instagram. As you can see, I'm opening my API 5500 because I'm gonna change the op amps. This unit came with 2 original API op amps and 2 Scott Liebers. These, the 2520, is a big part of the API sound. These are Scott Liebers. So, first of all, shout out to Scott. He's been super nice. He sent me these super quick. Thanks, Scott, if you're watching or if you will be seeing this at some point. Anyway, you will find these in any API piece of gear, including consoles. The problem with these things is that they blow up. What I'm gonna do now is I'm gonna swap them. Now the beauty of these, they're plug and play. Many people like me like to swap the original 2520 for the Scott Liebers because they sound a little smoother and, most important, they don't blow up. Now finally these 4 will match. Make sure that the little feet are in and push them in. And this is the second. That's pretty much it. Some people don't even hear that much difference. There's not that much difference, to be honest. For the most part, I keep these for reliability, and I'll keep these just in case, you know, something happens, but the EQ is matching. That was my task to do tonight. And I thought I would pop up online and share it. I'm about to release a highly advanced mastering course on the channel. This is the real stuff. So the first part is gonna be available for everybody, so people can get an idea of what it's gonna be. And the second part is gonna be for members only. This is gonna be an advanced handful of techniques for mastering. No bullshit. I'm not bullshitting you. You will not find the stuff that I cover in these videos anywhere else from anyone else. You can call me out if that's not true when the videos are out. That's why it's going to be members only. You will be able to see the first part so you can get an idea and decide. This will probably be in collaboration with a company because the course is based around a specific unit which was unavailable up until a couple of years ago, I think, in plugin form because it was impossible. And the unit was like over 10 grand. So not only you wouldn't see them around, there was no plugin for it, and very few people had hands-on experience with it. And even less we're going around talking about it. So there's not many people who know how to use it correctly, how to use it for specific things that I will cover in that video. Actually, it's not a video, it's a 2+ hour course on mastering. API's got new op amps. I gotta go back to work. Before I do, stay safe. See you soon.
Hands on my neck, hands grip my throat. Lift me up, man, take control. Heart is so gone.